Hello everyone. In this particular video, I'm going to tell you, or I will be discussing the solution to the problem that is, if you have been given a vector such that of any kind, like there are three numbers, or a string is given of the number of letters which will be having like n characters, what you call. So, how you will be generating the permutations of the given string or an array. Now, from a given vector or a string, you can simply know the number of permutations that will be generated. Like that has its formula simply is equal to n factorial. And here in case of a string or a vector, the number is 3. So you will be getting 6. So there will be 6 permutations. Now, like you can do it in two ways. So one of the ways is using a map which will lead you to avoid the number duplicates. The other way you normally must have heard of like swapping. So here in this video, I'm going to discuss about the map that is using hash map and all. So this particular is a map which we will be creating, and its length will be equal to the length of the given vector. Like here, the length is 3. So the length of this particular map will also be equal to 3. This is the particular case. Now, moving on, what we will be going to do. So our next step is as simple as that we will be creating here a recursion tree. Simple. So how we will be starting? Now you know that at this particular index, just understand this. At this particular index, or if you want to generate the permutation, you have three options. So here let's not make it that complicated. So you have three options. You have got one, two, and three. So you can start from one as well. You can start from as two as well. You can start from three as well. As simple as that, isn't it? So our starting index, like you have to, for getting the permutations, you have to initially start from some particular value index. So here you can start from this particular index as well. You can start from this index as well, and you can start from this index as well. So suppose we have got the one is the your data structure, as simple as that. Suppose what we will be going to do. Initially, we have to figure out our starting index. So our starting index can be as simple as that. We will be getting here one index and the let me do starting parameters of the given function will be as simple as that. There will be one starting index and there will be another one will be a data structure which will be temporarily stored. That data structure I have represented here by the letter D. So moving on, we have what? Like now we can check for another, like we can start from, as I told you, we can start from any of the three numbers because we have to generate the permutation. So suppose if we start from the index 1, so we have now, like we have started from 1 and we will do what? A data structure will be having 1 and we can make a map, what we have been using. We can make a map and we can simply write here as, we can check this out, as simple as that. We can mark it uh, as 1. Now, 1 here signifies like true and false in Boolean we take. So 1 here signifies as simple as that, that this particular value has been taken. Supposedly, if I start from 2, just take this into account. Supposedly, if I start from 2, then my data structure would be having this particular value 2. So I can say that in that particular case, this got 1. Now, supposedly I started from the last, that is 3. So what I'm going to do? I'm simply going to do what? I'm simply going to mark 1 in the third. So these ones signify that these particular values have been taken. As simple as that. These particular values have been taken at that particular index. Remember, this is one more point to be noticed. Remember what? Map here signifies that these values have been taken and at these particular index. You can also call these maps as frequency arrays as well. That is not a big deal. So now your the particular data structure has either got one or two or three based upon this particular problem statement till here. So moving on, supposedly if I was at one and D has got a one. So now next combination can be there are two possibilities. I can't take one again because it has been already marked. So there are two possibilities. I can go for two. So that will result into both of them being marked one. And the other option that I have is that I skip two and I take here like three. Not exactly three, sorry. This is not the index. Uh, this is just correct this out. I actually wrote it in the manner supposedly it's zero. So this will become one, this will become two. Okay. And if I go this side as well, so I have to check this. So remember, just don't blindly write it. I wrote it in terms of the number, element number, but we should write it in the method of index number. So here the index will be zero, here the index will be one, and here it will obviously be two. So hopefully you have corrected this. I wrote it in terms of the element number, but it should be in terms of index number. So like now, as simple as that. If the one has been marked, that as one being marked simply means that it has already been taken. So now this particular has got two possibilities. That is either it can take the element 2 or it can take the element 3. So if it takes element 3, then your data structure has got now two elements, that is 1, 3. And you will be marking this and this as 1. Okay, as simple as that. This is. Now, you know the left side recursion is executed first. So as of now, if I rewrite the value of D as this particular state, so you have got the value of D as 1 comma 2, or you have got the value of D as 1 comma 3 according to this particular state. Now left side recursion is executed first. So what you are going to do? You are simply going, I don't have that much space here, so I'm taking it to the next page. So what you are going to do here? You are at the index 1 and your data structure has got 1 comma 2 at the moment. Now there is no possibility other than taking the last element. So you just have got one possibility, and that is you can take the last index, and you can simply do what? You can mark all the three as 1, 1, and 1. As simple as that. So now your data structure has got 1, comma 2, comma 3. Now, how you find it? You have got that this particular data structure. Now you know, like if there are three elements in a given vector, so no, its permutations will always be having its permutations. Remember, it's not subsets. Its permutations will always be having the elements like the same number of elements. So you know, as soon as the size of the given subset which is holding the permutation becomes equal to the given vector, your that particular permutation you have taken. So here you have got it, and its size has become equal to the given vector. So you will simply push this into a particular vector, which will be a vector of vector, and which will finally be returning all the permutations. So you will push this. Now, When you have reached this particular index, then you will also be having a return. So return will do what? Return will simply take this back. Like return will simply take this back to this particular stage. And while coming to this particular stage, that while you are doing backtracking, you have to uncheck this element. You have to make it what? You have to uncheck this particular element. And uncheck means what? You will simply make it like this, as simple as that. You have to uncheck this element, and you have to also remove this particular tree in order, because at this particular stage, your D, the particular data structure which was holding the value, has got 1 comma 2. So now you have reached this particular stage. Now, the other possibility that you got at this particular stage, like this part is over now. So you have got another part, that is you will be backtracking here, and you will be simply doing here what? You will be backtracking here, and you have now got the value. Like at this particular stage, you will backtrack here, you will pop this element, as simple as that. So now this element has got what? This element has just got 1 in it. So this part will come to execution. So now 1 and 3 have come. So after 1 and 3 have come, what is the possibility? What is the possibility? So you have marked 1 as well, you have marked 3 as well. So the next possibility that will come will be 1 comma 3 comma 2. So in this manner it will execute. Now, in order to guess the time complexity, you have got for each of the values, the number of choices are similar to, like for each and every element. Just to take this into account, like for each and every element, as simple as that. Remember this, for each and every element, or for each and every index, not element, but for each and every index, you have got two possibilities here. What? For each and every index, remember this, for each and every index, you have got two possibilities here. So if there are n elements in a vector, if there are n elements in a given vector, so initially your time complexity would be simply n, and then you are, sorry, if there are n elements in a vector, then simply you have got the number of possibilities as 2 to the power n, and you are pushing these subsets as well inside a vector, so it will also take into account an n possibility. So your time complexity would be big O of 2 to the power n into n. Your space complexity would be the number of permutations that can be generated will be n factorial, and like its possibility will be simply, and the average length, here is no concept of average length. You know the length of the particular permutation will be equal to the length of the given vector, so that will be n. So n into n factorial. And your auxiliary space simply depends upon the number of recursion calls. So you can find here the number of recursion calls are somewhat is equal to the number of elements inside a vector. That is your stack space. So that clearly represents big O of n. So this is big O of n factorial into big O of n, your space complexity. So I hope this basic idea is clear. Now we will be moving to the code to get you a better idea. So here in this particular, you can find that this is the particular code. Here what I'm doing. Initially, I have created here a function which will actually do what? Which will firstly find a particular permutation. The function, this particular permutation, that is the first function inside this program will do what? It will simply actually find a permutation, and when it is found the permutation, like when its size has become equal to the size of the given vector, it will simply push it. Now, how it will calculate the permutation? Now you know, like permutations can be, elements can be from any side. Like any side, what I mean is like your starting index can be any of the three. If for a vector of length three, and like somewhat if 1 comma 3 is there, then the next element that is like is missing, you will be placing it inside a permutation. So overall, if you have to, your first index can be any of the three. Then in order to check for all the index, then you have to run the loop that will be from 0 to the less than size minus 1. Now, this is a condition. Now, this is what? This is simply, I'm writing here, this is simply if your, I'm sorry, I can write it here. If the map is unchecked, this condition will be checking that for a given particular index, that particular index has got one or not inside the given map. Because if it has got one, then it will not actually push it inside the particular temporary data structure. So it what? If it has not got one, then it will do what? It will simply push back that particular element inside that, and it will just mark it one. Then you will iterate it again, as simple as that. You will do what? You will iterate it again, and while you are iterating, you will simply do what? Till the time the size becomes equal. Just remember this. Till the time its size has become equal to the size of the given vector, its size has become equal to the size of the given vector. This will go on, and on. As simple as that. As simple as that. This will come, go on and on and on. As simple as that. So, what you will be doing here? As simple as that. Just take this into account. So, you will simply do here till the time when its size becomes equal to the size of the given vector, it will simply push back this particular data structure into the final data structure, and it will unmark it also. Now, when you are returning, then you have to unmark the map, and we have to remove that particular element as well, so that when it comes again, it doesn't find that particular element. This is what it is. Now, if you ask me how it runs, if you just want to get an idea, like how it is actually like, so see, if you take initial index, any of the two, suppose if you're taking and you find that at this particular index it was not changed, then you simply push this element, isn't it? Now, when you push this element, you mark this one, and then you recursively call it as well. Okay. When you recursively call this particular element as one, now your first part is done. Now you have to move, like you have to move to another value. What it is? It will, you have to move to another value. Like you, if you just go to this particular value, what you did here? Initially, you took the zeroth value, like you can take any of them. Then you have to check that can I take the value again? As simple as that. Can I take that particular index again? So you have marked it, you can't. But you have to check it. Though you have marked it, but you have to check it. As simple as that. So you are again checking. Can I check the no? So I will become this time one. So this loop has to be run. Otherwise, you won't find that which particular index, like the map is marked or map is checked. This is them. Then I have used public here because I have to call it inside the main. So this vector will simply do what? This vector will simply create here. I have declared here a vector, and I have actually just simply did here what? I have simply created a temporary data structure. This will store all the permutations. This will store a particular permutation temporarily. This is a frequency array or a map you can call of size equal to the size of the given vector. And this is a function used to initialize, because initially the map will be unchecked. Remember, initially the map will be what? Initially the map will be unchecked. Remember this. Initially the map will be unchecked. So this is the function, or here you can also use, remember this, or you can also use here memset function, as simple as that. You can also use here memset function. Both have their time complexities as big O of 1. So then you will again call this particular permute. Those two functions are different. Like this one is from small and this one is from capital. The functions remain the same. Like their spelling is same, but their working is different. This does what? And then you finally simply return. Like you return. Like initially you do what? This is a function which will return. So finally, using this particular permute function, you are doing what? You are actually pushing the elements inside the answer vector. And then you are in this particular function, you are simply returning this particular answer vector. And inside a main, you are declaring particularly your initial vector. Then you are calculating its size. And then you are doing here what? You are simply creating another nested vector using the solution method. You are calling it. You are, because you are returning the answer vector, so you have to take it. And this is the method of actually just simply printing it. So this is all about its code. As soon as we run this code, we will hopefully be getting our answer. And let us see what is the answer. So answer is 123 132 213 231 312 32. As simple as, because you can't take those elements again, so you won't be getting here as 123 and then another all those things. You know simply that permutation for three elements will be six. You can find here the number of elements as six. So that's all for this particular video. Hope you understood it, and thanks for watching. Do like, share, and subscribe. Thanks all for watching.